Hi friends, in this session we are going to discuss about some interesting patterns. Friends, there are many things around us which follows some specific patterns. In the example of this stair, the height of the first step from the left hand side is 3.5 feet. The second step is 3 feet, third step is 2.5 feet and the last step is 2 feet. It means every next step is getting reduced by 0.5 feet. Here is one more example. A man deposited 1000 rupees in a bank and it gives 100 rupee as an interest at the end of the year. So at the end of the first year, the accumulated amount will be 1100. At the end of the second year, it will be 1200, then 1300 and so on. So every time 100 rupee is added to the previous amount. In this session, we are going to discuss about the patterns where the succeeding number is formed by adding a constant number to the previous number. Let me share with you a fresh example of such pattern. I have got a new project by a company and I have to complete this project within 30 days. You can consider this table as a table of 30 days. And the pattern in this example is the mode of payment. That is, on first day of the project I would get $10 and on second day it will be increased and I would get $15. On third day $20, on fourth day $25 and so on. Here the mode of payment is in such a way that the succeeding payment is incremented by $5. You can consider this table as month of November. Here every number is increased by $5, that is, it is progressing by $5, and since we are dealing with the numbers, therefore such pattern is called as arithmetic progression. The short form of arithmetic progression is AP. On 21st November, that is on 21st day, it's my friend's birthday and I have to buy a gift for him. But exactly I want to find out how much payment I would get on 21st day of this project. So accordingly I can buy some gift for him. But going this way, that is adding $5 to the previous payment and get the next payment, seems quite lengthy. I want to find it in a very quick and easy way. And I know that every missing things becomes easy with the help of observations. So even I'm going to observe this and find some easy way to know the payment on 21st November, that is on 21st day. Let us see, on day 1 I am getting $10. I am not putting dollar sign over here. Then on day 2 I am getting increment of 5, that is 15. On day 3 now the increment is doubled, that is 5 into 2 and it would become 20. Similarly on day 4 the increment is 3 times and I'm getting 25. Now we can observe here on day 2 the increment was 5. So we can write 5 as 5 into 1, and similarly on day 1 we can write it as 5 into 0. That will give me 10 only. So observe here, on day 1 increment was 0. On day 2 there was 1 increment. On day 3 increment was doubled, and on 4 increment is 3 times. So we can say that on day 21, that is on 21st November, the increment will be 20 times, that is 10 plus 5 into 20, and it will give me 110. Friends, let's generalize it so that we can find out the payment on any day. Let us denote the payment on first day as first term, that is T1, where T is term and suffix 1 is the first term, and the second payment as T2, third as T3, then T4, T5 and so on up to T30. So we can write T1 as 10, T2 as T1 plus 5, where T1 is the first term, that is 10, T3 as T1 plus 5 into 2, T4 T1 plus 5 into 3. So if we are generalizing it for any number, for any term, let us denote it by Tn, where T is the term, where n is any number. We can write it as T1 plus 5 into n minus 1, where 5 is the common difference. Let us denote common difference as D. Now we can write general expression as Tn equals T1 plus n minus 1 into D, where T1 is the first term, n is the number of terms, and D is the common difference between any two numbers. Let's use this equation and try to find out the payment on 30th day, that is on 30th November. So by using this formula, we will write T30, instead of n we'll write 30, and T1 plus, now here n is 30 minus 1 into the common difference T. So T30 will be equal to T1, that is 10, plus 29 into the common difference is 5. So the payment on 30th November will be 155. So on 30th day, that is on 30 November, I will get $155. Here we have got the general expression for any kind of arithmetic progression. By using this expression, we can find out any term of that progression. Now let's go to the next step and try to find out the total revenue I would get by this project. That is the summation of all 30 payments. Now we want to find out the addition of all the 30 payments. That is 10, I'm not writing the sign of dollar here, 10 plus 15 plus 20 plus 25 plus and so on to 155. So friends, can you tell me the total amount? You know friends, a similar kind of question was asked to a boy in a school, that is, what is the addition of first 10 counting numbers? That boy answered this question very quickly. Let us see how. What did he do? He write this expression as S is equal to summation of all 10 counting numbers. And then again he wrote this expression but in reversing order. Then he added these two expressions. Now S plus S will give you 2S, 10 plus 1 is 11, 9 plus 2 is again 11, and every time you will get 11. So we will get 11 10 times. Since there are 10 numbers, we can write S as 11 into 10 divided by 2, that is by getting 2 on the right hand side. Now 2 5s are 10 and 11 into 5 is 55. So he got this value as 55. We are going to apply the same logic to find the addition of all 30 payments. Let's do it. Let's write S30, where S denotes the summation and 30 denotes the summation of 30 numbers. Now we can write it as S30 in reversing order, that is 155 plus 150 plus and so on, 20 plus 15 plus 10. Let's add them. We'll get 2 times S30, and the addition of 155 plus 10 is 165. Again 150 plus 15 will give us 165. So we'll get 165 how many times? So we can write 2 into S30 equals 165 into 30, and next step will give us 165 into 30 divided by 2. So by cancelling out, we will get 2475. It means the total revenue by this project is $2,475. Now there will be a question in your mind that can we generalize it also? And answer is yes. Let's do it. Let's try to generalize it. We can also write the last expression as S30 equals, now I'm writing 165 as 10 plus 155. You can also write it as 155 plus 10 into 30 divided by 2, where 10 is the first term and 155 is the last term, that is T30, divided by 2 into 30. So we will write Sn is equal to first term, that is T1, plus Tn, that is the last term, divided by 2 into the total number of terms. By using this expression, we can find out the summation of any arithmetic series. We will not stop here because we can generalize it further. We know that Tn is equal to T1 plus n minus 1 into D. So instead of Tn in this expression, we can write T1 plus n minus 1 into D, and we will get Sn is equal to T1 plus again T1 plus n minus 1 into D. Let's take 2 out of the box into n by 2. So the final expression will become T1 plus T1, that is 2 times T1, plus n is the number of terms minus 1 into D, that is the common difference, into the total number of terms divided by 2. So if we have to find out the nth term of any arithmetic progression, then we will use this formula, and if we have to find out the summation of all the terms, then we can use one of these two formula. Both will give you the same answer. If you are using this formula, first of all you will have to find out the value of Tn, then you can go further, where in this case you can directly use the formula if you know the first term, that is T1, number of terms, and the common difference, that is D. So use this formula to find the nth term of an arithmetic progression, and you can use any of these two formula to calculate the summation of n terms. Let's have a recap of this session. I hope you like this video. If you have any query regarding this session, then write it in the comment box